5 units. So that here the application part we will see. Till yesterday we discussed about remote sensing and uses of GPS, application of a GPS and GIS. How the GIS will be useful in creating part of different images, what we have collected from a field with the ground data source. So here the land resources, the application point of view in a remote sensing and GIS, in a particularly environmental studies and management. So here basic applications, if you wanted to see the land resources, mainly we will study here the evaluation of a land and suitability of a land for different purposes. Um, uh, Along with that, we see the land capability and land irritability classification, the role of remote sensing and GIS in a land use and land cover. It is also having the classification. Based on that classification, the remote sensing, how it is useful in a environmental studies. Here also we can see the different visual image interpretation of key elements. Those also again once we will study here. Um, in the land resources, there are various types of land formations and uh, different types of living organisms and non-living organisms will be covering on a surface or a land. So the sustainability of different organisms or different resources, what they are arranged on a land, those we will study. Almost we see in our country depend on their rationalization and scientific or regional or according to the regional and urban planning, the reliable and integrated information we have where the land use planning is required, or sometimes maybe the data maybe it is not available. So here in a present context, we will study the information of a land use and land cover with the using of a different thematic layers or collateral data, and it is insufficient and so not to provide the latest information. For the last 2 decades, satellite remote sensing were used for the generation of land use information. Land is the most important natural environment for all the activities of man. So here, almost um, we will study about the maps and the availability of a soil types depend on the population growing, and more activities will be done and more resources are required for human existing. So in olden days, almost at the time of independence, at the time for independence, the per capita of land is available. It is available, cultivated land, it is available. That is as per calculation of 1951, 0.48 hectares per man. But the same calculations were carried out in 1991. There is a differentiation from here, there to here. So here, what was happened? Oh, the land, it's almost was utilized for different purposes. So the land it was available in 1991 only just for head. It is a 0.22 hectares. So now you see the differentiation here. The use of man activities are high. What you have done. So the land it is used, but what about land cover here? The land cover it is covered or formed by the different vegetational and artificial constructions and covering the land surfaces. The types of land use and land cover categorization is developed in a classification system. In a classification system, which can be related the land capability and vulnerability for management purposes, for management practices purpose, which is used. So here, the improvement of usage of the land, and it is including the productivity of land spaces, different species what we have seen, and the different species were provide, and as well as the climate and the study of a biogeochemistry and all the hydrological science which are playing a very important role in the formation of the same. So sometimes we may see in a land cover and land use which is showing the impact and same uh, climate and as well as environmental studies, yeah, biogeochemistry, hydrology, and other diversity and plenty of diversities, plenty of diversity is available on the terrestrial species. So the GIS and remote sensing gradually it is becoming it is an integrated technology which is being widely used in various applications. Yes, we can use it is in a different application purpose and different application point of view. So the a spatial display which is having a or a spatial display techniques are provided for a GIS, and in a remote sensing image process, the visualization techniques will be applied, and later we will create a image or we will modify the image based on the availability of a ground truth data. Yeah, the land use may it is involved either into the shift to different purposes or different use. Here we can see the land uses purpose. Different various types of purposes will be there. According to that, yeah, according to that, the land will be useful in a small scale level and as well as a large scale level. So the soil evaluation and suitability studies. Soil is major component of a land system, which is provides the medium for plant growth, the potentials for sustainable use and agriculture, horticulture, or silviculture and forestry, as well as its a response to irrigation and other management practices are controlled by the inherent qualities. So here we'll apply the remote sensing system and remote sensing applications for the development of aerial photographies. Based on that aerial photography, we will carried out. We will carried out the different images, and those images will be identified the data based on the ground truth data. We will classify that, and later so we'll classify that, and later we will apply the different what we are what we are features have been identified on the surface, and those will be applied. So here the soil resources, the information is need to translate it into the which what we have seen or exist, and those we will consider, and what are the features are identified, and what are the sustainable agriculture development is going on there on a surface. We will identify that, and according to that we'll make a plan to whether the land it is useful or not. We will generate and we'll take a action. So here land capability and land irrigability, and as well as land suitability, it is also playing the very important role commonly where we are using the land. In this case, land capability classification, there are three types of classifications are there in a uh, in a land capability. One, it is inherent soil characteristics we see, and second one, it is external land features. Third one, it is environmental factors. So according to this, there are there is a classification. There is a classification, and which is classified into the eight types. The class one, it is the first, second, third. It is includes the land suited for regular cultivation. Yeah, these depend on their soil texture and the soil types and availability of a features. Features. Those features are required. Those features required for classification of a soil. It is including whether that soil it is suitable for cultivation or not. That is important. Yeah, these three first one, two, three. These soil types are suitable for regular cultivation, as well as four class four and uh, five. Okay, class four. Actually, it is also looking good, and this is also cultivation and support. It should be supported to the cultivation, and depend on their by natural features like slope, erosion, a little bit of soil characteristics. I mean, characteristics means here the texture type, grain, or color. It is also color and composition of a soil types, which sometimes maybe it is not suitable for cultivation. But whereas class fifth, sixth, and seventh are not suitable for any cultivation. Yes, exactly. Class fifth, sixth, and seventh. Why it is not suitable for a cultivation? Here, maybe some the soils are not mature and not fertile. Depend on their maybe it is a hilly area or valley portion, a little bit of a forestry, and the land surface features. Sorry, the land surface features are a land surface. It is having the more boulder type formations, so that those are not suitable. Those areas are not suitable for uh, cultivation purpose. Yeah, next class seventh. This is suited for only for wildlife recreation because of completely it has either maybe it is a plain area or maybe it is a hilly area completely, so that it look like it's a very dense forest. It will be created so that the Eight type of soils are not suitable for particularly agriculture purpose or cultivated purpose. So according to that, this classification has been done by the All India Soil and uh, Land Use Surveys. Land Use Survey. According to that guidelines, the classification has been done. So later we discuss again the land use plan, and will come in further slides. It will become. Uh, yeah, before going to that, we see the land degradation also. The land degradation here, either maybe it is the loss, whatever uh, we see, the sometimes we see it as a permanent, sometimes we see it as a or temporary productivity. That means here the production has uh, it should be high. Some uh, this, uh, heavy rains, the removing of topsoil, so making the soil infertile and hence unsuitable for agriculture. So here, due to the heavy rain, what is happening? The occurrence of heavy rains or due to the heavy rains, the more water will flow on the surface and uh, surface, and then washed out everything material, whatever material if it is available, the fine material or a medium or a coarse grain material, whatever it is available on its surface, those will be washed out due to the heavy rain or due to the overflow rate of water on a surface. So automatically, which will be completely removed on a surface. That's one thing. Second thing, it is natural disasters. The natural disasters are like earthquake and floods, which can have a considerable impact on land resources. Definitely, definitely. Suppose due to the more earthquake eruptions are there, or more earthquakes occur. So that's also impact. That is also impacting on land surface, so that the original and the originality will be lost on the same. So that is the major fact. Due to that, the original soil will be lost from there. One more thing, it is high speed winds. The high speed winds, because of the intensity, it is more. So that the topsoil may be sometimes the topsoils, maybe it will be removed and flown and um, transported from one place to the another. So the topsoil, maybe it has a softened material and more minerals are there. Humus material will be also there on topsoil, so that is the one reason it will be completely washed out from that area, from that area where it is at. So almost due to these reasons, we will get uh, unmatured soil. Unmatured. There is no fertile soil. So there is no maturity in the soils. So that these are the conditions sometimes may be see due to the above mentioned factors. Yeah, one more, it is a salt affected soils. Here, the salt affected soils means here they depend on their uh, alkalinity. Whether the soil types, they depend on that. The soils which are categorized belongs to the saline soils, or alkalis, or moderate alkali, or slightly alkali. See, depend on their pH categories. We see that the pH and electrical conductivity. According to that, it is classified. The land cover characteristics, and what we will see. Suppose on a image, there are different tones will be available on a once if you are extracting the photograph in this area, the image characteristics also we see. Yeah, third one it is the soil characteristics. Yeah. Uh, Completely barren with 1 to 4 centimeters of salt cover. The salt, which is salt, maybe it is a covering in different areas. The pH maybe it is almost 7.9 to 8.8. Yeah, 7.9 to 8.8. But whereas alkaline, saline will be there. Salt we can see here. The thickness of a soil, it has a 1 to 4 centimeter, which is covered the salt material on the surface. Uh, White tone with bluish streaks on a surface. We can see white tone with bluish streaks. Small fractures will be seen on a surface. So the bluish streaks we can see between this range of a pH and as well as the EC conditions, electrical conductivity conditions, ion exchanges. Due to this ion exchanges, mm, the electrical conductive will impacting on soils. The second one, it is a completely barren with 3 to 8 centimeters of salt. So here, what is the pH range? The pH range almost 9.8 to 10.4, 9.8 to 10.4 between that range. And EC, you see here, little bit it is 50. It is showing the 3.9. That means 4 to 50. 50. So there is a huge differentiation from first one. In a first case, saline science EC it has a 4.5 to 10.6 only. Yeah, in a second high alkali zone. In a high alkali zone, alkalis will be there. Alkalis will be there. So that like sodium, potassium, those will be materials will be there. I mean mineral elements will there in that composition. So that is the reason it is showing the uh, high alkali category. The image characteristics white with yellow streaks. White with yellow streaks. That is on yeah, barren land and supporting salt grasses. The soils are having the moderate alkali. EHC range it is 7.0 to 8.6. pH it is indicating the 8.9 to 9.8. The image characteristics. The image characteristics are light pinkish, gray plus and yellowish tone. We can see that is in a light pink and as well as a gray yellow tone. Yeah, suppose maybe if it is decreasing the salts. The color maybe it is different from previous one. Yeah, next one it is patchy crop, patchy crop stand. Yeah, okay. The image we can see here. The image it's a bluish gray. Along with that, red patches also we see. Oh, it has a very slightly alkali, slightly alkali. pH maybe it is between 3.2 to 6.2. Sorry, EC 3.2 to 6.2. pH is maybe 8.5 to 9.4. So here, in a general classification, we see the pH of soils or whatever it is that we know that almost 0 to 6.5, 6.5, we see it is in acidic nature. In 6.5 to almost 8, it is indicating the neutral, and above the 8 to 14, 8 to 14, we see that is as a considered alkali stage. So here, the normal classification, that is when we compare with this one, slightly little bit marginal changes are there in a 0 point, sorry, say 6.5 to almost 8, and we will consider that is a acidic stage. So it is neutral stage. It is a neutral stage, and that, above the 8 and above we see that is as a consider, we will consider that is alkaline, because of here the most sodium and potassium uh, elements will be released into the soils. So the soil color will be also changed for sometimes. So depend on their depth of a salts or availability of a salts and composition of a soil and the soil category. According to that, we will take a necessary action and we will give a treatment to the same. Yeah, next, coming to the classification of soils. The classification of soils. Uh, what purpose we'll do the soil classification, and how do we classify the soils, and how we can explain or what is a land capability class? What is the soil classification system? Uh, these at least minimum knowledge we have, and we'll go for further studies. In a soil profile, if you see according to the section, cross sectional, it has a different layers. Those layers are called as a origin. Yes, each layer, it is showing the some characteristic features or characters: the thickness, color, texture, structure. This. So if you see in a uh, soil classification or a soil profile, we can see it is classified as origin A, origin B, origin C, and origin D, that is known as a bedrock, according to the thickness of a soil and color, texture, and arrangement of a different formations in the form of a structure, according to that we see. So the same origins, A origin we will call that A origin. It is known as a topsoil. It is known as a topsoil. The topsoil 1 to 3, depending on a origin or depend on their formation of a soil in different regions. According to that, the thickness may be in C. You can see that is rich in a humus, and soil organisms will be there, and plant roots or plant organisms, and biotic and abiotic small organisms also we can see on a surface in this origin. In this origin, and later origin B, it is known as a subsoil. It is known as a subsoil, but there is a differentiation from previous one. Yeah. And some of the areas are having the fine grain textures, or sometimes we are unable to see the fine grains. The color it is also changed. Almost the color we can see it is a brown to orange or brown origins, and it is a accumulation of clay minerals. Different minerals are there, and a little amount of iron we can also we can see here. Inclusion of organic. So completely it is a compact of blocky in some other areas depend on their terrain, or sometimes we see it is a prismatic structure. So here the origins of a maximum in A, and A it is also classified into the A, sorry, 0, A1 and A2. In A1 and A2 are above the A1, it is known as the or it is known as a humus material. It has a humus material, and the color it is also different, and a huge amount of debris material will be also there. We can see, yeah. From here onwards, the A it is going to be started. A and B and C, and later D or hard rock, or we will call bedrock, that is the hard compositions we see. So that there is a differentiation here. You can see above the A till here is it has a different grain size also we can see here. So that here mixed composition and mixed mineral compositions will be seen. The color light color argent will be seen, and origins of maximum biological activity of evaluation, removal of a material suspended or dissolve in water, or sometimes you can see it is mixing of different compositions there. So that is the reason automatically we'll get a different color in a origin, and the A origin, and later what we have seen, this is a B origin. A B origin, the color it is a different here, and the presence of a different clay minerals, present of a different minerals are there along with the K, and sometimes we see the along with the clay, the iron rich soils also we see in a B origin. So these two inclusion of A and B, these two A and B, we will call this is known as a solum. It is known as a solum. And later coming to the C, the soils of a C organ, the parent material will be there here. The parent material it is derived by the weathering procedure, so that here the soils will be joined and placed here, and they will be formed layer by layer. So some of the soils we can see different formation and mixing of with others. Or in some other areas, there is no mixing with the other soils. So monocolor we will identify here. Monocolor we will identify, and later final one it is origin uh, R. We will call that is as a bedrock R. Yeah. Yeah, these two origins, what I told you just now about the A origin, it has organic matter. It has organic matter, whether it is a plant or animal lives, organic plant residues, and decompositors also we can see. Yeah, next one after the yeah bedrock will be seen. That is maybe 1 inch to the almost 1,000 inches. We can see. Yeah, land capability class. Here, the land capability class, it is a projective potential of soil based on the soil type or maybe soil structure, slope, depth, and texture. The soil, whether it is useful or not, or whether it is suitable for agriculture purpose or for other purpose, whether it is suitable or not. A class one best it is for agriculture production. In class 8, you know that what I told you just now for class 1, 2, 3, these three types of classes are each is useful for cultivation purpose, for agriculture production purpose. Class 4, okay, it is also useful, but compared with previous one, it has a less capability to grow the paddy or to grow the crops, or it is not perfectly, it is not suitable for agriculture purpose. Yeah. Here it is given very detailedly. You see, there are some limitations are there, and the restrictions are there for the using of the class one soil, but it is suitable for agriculture purpose. It's the best for agriculture. A class two, the moderately limitations, it has very moderately limitations, and that reduce the choice of a plant, or that require a moderate conservation practices. Class 3, severe limitations. It's occurred severe limitation to reducing the choice of a plants, requiring the very careful management for both. Uh, the severe, it is slowly, it is increasing. You see in a class 4. In a class 4, yeah, in a class 4, very severe limitations, reducing the choice of plants, or requiring a very careful management of both. Class 5, not likely to erode, but have other limitations also. You see, uh, in practical, to remove the limit depend on their usage. Class 6, severe limitations which making them generally unsuitable for cultivation. because of these soils are not having the stability conditions. So perfectly these soil of a class 6, it is not suitable for cultivation purpose. Maybe it has hill stations, or maybe it is a valley areas. Up and down or undulations portions will be also seen on class 6. So that is the reason we are unable to cultivate these type of soils. Yeah, class 7 and 8. Yeah, 7, very severe limitations making them unavailable for cultivation. Maybe completely it is a hill area, it has more boulders, maybe it has. So that is the reason it is not suitable for that. The last one, it is class 8. It is suitable for only wildlife, forest, forest, and to create the forest areas. Because of that area, maybe the land it is not more fertile. So that is the reason it is suitable for to making of this. There are sub classes also indicating depend on the major limitations within class. Yeah, class one has no class one has no subclasses. We see here the remaining E subclass E, it is a risk of erosion unless close grown plant cover is maintained. And subclass W, it's a water. We you see that is a water infill. It has a more infiltration. So which soil which interferes with the plant growth or cultivation process. Yeah, S here it is showing the shallow and droughty and the stony areas. The soil classification system developed by the USDA to categorize the different types of soils which exist. So almost all soils broken into the 12 orders. And again, it is divided into the further uh, availability of soils. Almost, yeah, almost we see the about 10,500 known in US. Okay, that is based on the US data, but no need to us. Yeah, it is a living organism style. There we will see the in a living organism classification: kingdom, phylum, class, order, family, genus, and species. Here the soils: order, suborder, grade group, subgroup, family, series, and phase. Yeah. Next, uh, availability of the soil, and yeah, and the land irritability classification. It is also there. The land irritability classification, uh, according to the All India Soil and the Land User, it has given some guidelines, and according to that guidelines, the irritability of land categorized into the five. A class A, this is depend on their soil formation and availability of sources. Class A, it is a non to slight limitations for a sustained use under the irrigation purpose. the limitations, according to that, the limitation maybe it is a severe limitations or moderately limitations. Whatever maybe it is that the class, uh, the use of land survey, the class A, it is indicating non to slight limitation for sustained use under the irrigation. Class B, moderate limitations it has. The moderate limitations for sustained use under the irrigation. Class C, severe soil limitations. It has a severe soil limitations for sustained use under irrigation part. Class D, very it has the sustained use under the irrigation part. And class E, this is not suitable for irrigation purpose. So these are classification. These are classification. It's a depend on their effectiveness of soil depth, soil texture, type of a texture, soil permeability, and water holding capacity, salinity. All these will be there. Now, next, what is the role of GIS and remote sensing in a study of a soil types or land resources? Yeah, before that, introducing of a ERTS1 in 1972, the mapping of a land use and land cover information is not available. Later, in 1972, after the ERS, your ERTS, the satellite, whatever launched in 1972 July. This is a land satellite. Yeah, it will be rotated near the polar orbit. It is a Earth-based satellite. It is giving the information particularly on agriculture and forest resources. Yeah, a little bit information also it is giving a geology and mineral resources, hydrology and water resources. These this information it is giving to us. Uh, so, what are the advantages of remote sensing in the using of land use land cover? In the using of land use land cover, repeativity, multispectral visibility, and cost effectiveness. And sometimes we see the synaptivity also. Yeah. Multi-spectral visibility, cost effectiveness, and sometimes we see the inaccessible areas also. Sometimes we may see, sometimes we may not get access to see the uh, that data. So the land use land cover classification we see the basic data it is required to us. depend on the spectral characteristics and the multi-band image, and which can be separate. In the spectral characteristics of multi-band image, which can separate in different land uses, so that the satellite-based land use cover classification, which is depend on their availability of satellites, and again the spectral characteristics, the presence of a spectral characteristics. It is covering the different land covers, and it must to be associated with each and uh, area, and using of land cover class, and the total image it should be classified. Uh, the land use land cover, which can be classified, depend on their depend on availability of resources, and as well as depend on their needs, whatever needs we are going to fulfill. According to that, we will classify. So, for that purpose, here we will see the data, whether it is spatial data or temporal data, or it has a spectral resolution. The spectral resolution, whether it is supporting to the image or not, that's also what we can see. So there is some methodology. According to that methodology, we will follow. The land use land cover map, it is prepared to obtaining and interpretation of data, and will follow the interpretation techniques. Techniques, the data it should be collateral data is required, and the data will extract from the Survey of India topographical maps and census records. The image classification, mm, it can be done by the using of visual uh, image interpretation, and visual image interpretation techniques will be applied, and the digital classification using in any of the image processing software, it is required. Pre-processing, we do the pre-processing. Yeah, we do the pre-processing, and rectification also we do rectification, enhancement, and classification. The classification, whether it is belongs to the supervisor classification or unsupervised classification, the data filtration, oh, and different processes will be done. So how we will rectify the data, the rectification data, and we will correct the information what we have seen on a ground, and the same portion of same, is it available or not there. According to that only we can see. So here the classification maybe it is uh, interpreted depend on their ground truth data. The ground truth stations, the ground truth data, it is playing a very important role for upgradation or for updating of information what we have seen on image. So here we will apply different elements, different remote sensing technique elements will be applied. As per that, we can do the classification and we do the modifications. Yeah, here the classification will be done in a different categories according to the land use land cover categories based on the NRSA land use land cover classification system is given. The NRSA means National Remote Sensing Agency. Now we are calling that is as a NRC, National Remote Sensing Center, and recently it was established established recently, and the study area land use and land cover classification system that is also we will see using the standard land use classification system proposed by the NRSA. About five classes of level 1 and 12 classes in level 2 and 4 level classification system we see in a third level third. The imagery is interpreted based on the ground check corrections. The classification system it should be adapted in the present area. And before going to that, just we see we have to know the what is the true color composition and what it is the false color composition. Please wait. Mm, yeah. Please wait. Here, there are two types of composition maps are there. One, it is true color compositions. True colors will be applied. In a false color composition, the second one. In a false color image, yeah, it is not correspondent to the what true colors what we have seen, like red, green, blue. The most common seen the false colors images. It is displaying nearer to the infrared rays. Those are red. Yeah, the red looking as a green, and green it is looking as a blue. These are the reflectance of colors. These three types of basic colors, which are the reflecting nearer to the infrared rays, and the colors will be not seen in a same color. So these colors are known as these type of color composition. It is known as a false color composition. Sometimes maybe it is generated artificial color image in which blue, green, and red colors are assigned to the wavelength depend on their wavelength depend on their uh, wavelength. So the wavelength sometimes maybe it is not captured clearly and it is not match. It is not match. Yeah, for example, if you see the false color composition, blue, maybe sometimes the blue it is assigned into the green radiation. The green radiation 0.5 to the 0.6 micrometers level. Sometimes, the I hope you know the ranges 0.4 to 0.5 indicating the blue and 0.5 to 0.6 it is indicating as a green and 0.6 to 7 it is indicating as a red color. So these bg are basic colors are these these tricolors are playing very important role in the formation of a image. So sometimes the green assigned, the previously just you have seen that is a 0.5 to 0.6. It is assigning to the green color. The the green color. Green it is assigning to the red, and red it is assigning to the nearer to the infrared ray that is 0.7 to 0.8 micrometers. Uh, What about the application point of view here? That is important. Suppose we see the vegetation, which can be detected on a image. The false color composition scheme is allows vegetation to be detected readily on the image. So here the vegetation appears in different states, different shades of. It's a depend on their availability of types. In conditions, it is also playing the important role. The condition of a vegetation type, station type. So we will see sometimes it is in a red color. The vegetation it is indicating the red color nearer to the infrared rays. Near to the infrared band. There we can see this green color. It is reflecting by the infrared, and will be shown as red color. You see here the red band near it. Almost it is the four. Here infrared, green band 3, red. It's the 30 meters of width, and band 2 applying the blue. It is indicating as a green, blue looking as a green. So here finally, uh, The adding of mixing of a colors, blue, green, red. These three you see here, blue, green, red, depend on their availability of a wavelengths, and it is reflected. Actually, it is, you see, it is in black and white channel. It is looking as a different, looking as a different. Near infrared rays, the green plants, greenery zone, it is indicating as a red, as a red. So that is image which was formed. The true colors you can apply here in a true colors. The nature of color combinations, whether the true colors or sometimes we see it is the color combinations are different. In a water penetration, you see in a water penetration, deep water, maybe the surface water we see that is it is in blue color, whereas yeah, whereas the deepest water can check the deepest. We are unable to see it is a blue. It has a dark. It has a dark shade or dark blue. We see the nature color combination. We see that is the water body. It is in a blue color, but whereas in the same water body we can see in a deepest, maybe sometimes the reflection if it is a change nearer to infrared rays, so we can see that is a little bit of a greenish color. The green we can, it is turned into the vegetation. The vegetation it will be shown in a red color. So these type of observations observed will be features are having different absorption capability and as well as to action capability for this one. Where in a heavy earth science features we see the color composition also in a standard false color composition. Healthy vegetation and cultivated areas like evergreen, deciduous forests or scrubs, cropland, fallow land, wetland vegetations. These are all it is reflecting here in a color standard FCC. The evergreen it is indicating as a red to magenta color we see. Deciduous forest zone we see that is a brown to red, and scrubs the light brown with red patches, pink to bright red, cropped land, pink to bright red, fallow land, light blue to white, like a white patches we see on your image. Water bodies, the water bodies clear water. We see the clear water dark blue to the black. Maybe sometimes it has turbidities. And this turbid water body we can see it is in a light blue. Yeah, build-up areas. The build-up areas, high density. The high density dark blue to the bluish green. Uh, Low density areas. The low density areas we see that is it is in a light blue, like a cyan color, light blue color. The wastelands and the rock formations or different outcrops, those will be also seen on image. We can identify the rock outcrops, light blue color, sandy desert and the river sand. It is in light blue to the white. Salt affected or deep ravines, dark green. Shallow ravines, light green. Waterlogged wetlands, uh, mottled black color. So these are the basic colors and the basic information. Once if you're going to create or if you're going to edit the things with using of these color changes, where we can see these color changes and the basic colors we can see on the true color compositions. The changes, the changes must we can see on false color composition maps. Here again, it is a mention the false color composition, any other combinations of false color you can see. You see here, blue band turn into the red, red band turn into the green, green band turn into the blue. Standard false color composition. The standard false color compositions near infrared band, near infrared band, red band green, green band we see it is in blue color, and in Indian remote sensing system band 4 it is indicating the red, band 3 green, band 2 which indicating in a blue color. So what are the advantages of FCC false color compositions? The false color compositions which allow and visualize the wavelengths of a human eye does not uh, see near the infrared range. Yeah, our eye which can detect and separate up to 30 shades of gray colors. So the extraction of information from grayscale color visually is a bit of a difficult and resulting the uh, less information. It's giving the information very less. For the application point of view, the monitoring of forest fires, surfaces which are having the elevated and temperatures, such as the forest fires and different volcanoes and different saturate, these will be identified on image. The most common pulsed color band combinations are we see on near infrared red color, and green that is you see in a blue, red it is in green, and this is the traditional and popular band combinations which are useful in seeing the uh, different changes in plant health. So various combinations are there in a false color compositions and in false color bands. Those we see. Wait. Yeah, it is categorized into three levels, depend on their density and availability of information. The build-up plan we see on a image, we recognize that is as a towns and the cities, villages, agricultural and cropland. It is also classified into the three types: cropland, fallow, and plantation zone. Yeah, that is Kharif season, depend on the Kharif season and Rabi. And double cropped also sometimes we see that is double cropped areas also. The forest, here the forest sometimes it is looking as a evergreen or sometimes semi. Yeah, level 3 we will classify that is as a dense deciduous formation. Most of the areas which are moist and dry. For scrub forest areas, the scrub forest areas we see it is as a dense. Yeah, sometimes we see the forest blanks in open areas or open type of a forestry area we see mangroves and forest plantations. Those will be also seen. Yeah, wastelands. The wasteland classification depend on their these pH type and availability of a different ions. We'll call that is known as a EC. Salt affected land, waterlogged land, marshy, swampy land, and land with a scrub, land without a scrub, sandy area, mining and industrial wasteland. Those will be also found. Parkland areas. Those will be also we see. Water bodies, maybe the water bodies, river streams, canals, reservoirs, and the water it should be stored in different farms. Other materials, shifting cultivation, grasslands, the salt pans, snow covered or glacial areas. These will be also covered there. The basic raw data it is required. So we see we will collect the from data source. The data source it is the basic information in our hand, and the secondary data it is also will have the basic data. It is known as a raw data or a satellite data. The satellite data it can applicable maybe if it is in a agriculture field. Kharif season whether that data you extracted Kharif season or Rabi season, that what we have take care of them, and we will check out whether the data it is belongs to the Kharif data or Rabi seasons data. And later in the secondary data, we will prepare a base map, and later we do the processing, rectification of a satellite data, the development of an interpretation case based on the image characteristics. Next, directly from Rabi season, the data interpretation and mapping of land use, land cover categories. Next step, it is validity and final, depend on their characteristics, and we do the validation and finalize. The ground verification of the doubtful areas and modifications of the thematic or themes will be developed. So next, the transfer the data, whether the Kharif, how much area was utilized for cropping, and similarly we compare with the next season. So finally, we'll get a final preparation of a land use land cover with the map, and the area it should be also estimate with using of a land use and land cover. Yeah, here given the classification system, yeah, build up land, the same towns and the cities what I told you just now. Those land use land cover classification system, which may useful for to carried out a case study also. The case study also we should carry it out. The land use land cover map we will make based on the availability of a data, and with using of a high resolution satellite data, then only it is possible to edit the or to visual the things. There may be chance to interpretation of data. So here the topographic maps also required. The topographic maps maybe you see on 1:25,000 scale or two seasons data it is required for a compilation study. So for case study purpose, the topographic maps, the scale it is a required 1:25 scales, two seasons data it is required. Kharif data and Rabi years data, these two are necessary. And in your textbook, it is mentioned very clearly the classifications. And just once you check out that, and mm, I'm stopping here. And tomorrow means the next class we'll discuss the geoscience applications and water applications also. Again, only two classes we have and four chapters. The remaining four chapters we will finish by coming week or for 2 days. And I'll explain the pattern of a question paper also and few important questions I'll send you a group. Thank you.